Hi, I thought I'd make a quick video demonstrating some new firmware I've been working on for my 3D printer. The actual printer itself is one I built myself over the past few months, and instead of using normal belt drives for all the axes, it uses lead screws instead. So I've got 20mm pitch lead screws for the X and Y axes, and then 2mm pitch lead screws for the Z axis. For the controller for the new firmware I'm working on, I'm using an LPC Espresso 1347 control board. It actually came with a JTAG debugger as well, although I didn't need that bit because I didn't really feel like using their proprietary development environment. Let's turn on autofocus so I don't have to keep doing that. The power supply I'm using is just a cheap one from Rapid. I'm going to be setting it to 20 volts instead of the normal 12. You'll see why I'm doing that later. And then the microcontrollers just interface into a normal Pololu stepper driver, which then is wired into the X-axis stepper. The stepper motor driver I just nicked from my ramps control board, which I normally use for the printer when I'm not experimenting. So if I power this on now, you hear a slight whine from the motor, which I think is the PWM controlling the current. And if I reset my controller, and off it goes. So I've got it set to a maximum of 500 millimeters per second and an acceleration of 2,800 millimeters per second squared. If I run that one more time, just to show you it again. So essentially the firmware is set to move to random locations, and then after about 30 or so goes, it will then just return to the start. If I now lower the voltage to the normal 12 volts, if I can see the screen, and then try and run it again, and the motor starts stalling and making horrible noises. So that's one advantage actually of running at the higher voltages, is it does give you a lot higher range of speed than the normal 12 volts. So I'll probably actually replacing this ATX power supply I've got here with a dedicated 24 volt power supply, although I'll still need to step that down for the 12 volt fans, and I'm undecided yet whether to switch the heaters for the heated bed and hot ends to 24 volts or 12. The reason I'm writing this new firmware is essentially I plan on, well, ultimately I want to make a touchscreen interface for my 3D printer, although to start with I plan on offloading a lot of the calculations onto a dedicated microcomputer, I suppose you call it. So in the meantime, I've this Raspberry Pi I actually got for Christmas. I've got essentially a breakout board which I'll then attach onto the other breadboard I've got and start experimenting with that. I mean, the Raspberry Pi itself is probably a bit underpowered, so well, if I decide to do slicing on it as well, then it may be a bit underpowered. So I might have to go for something else, like maybe the Beagle Bone, maybe. Now, one last thing is, you may be wondering why I'm sat on the floor here. I'm actually lodging at the moment, so I'm at university, but I'm doing a year in industry. So the amount of space I've got to work on my projects is fairly small. So I've got my 3D printer on the floor, and yeah, a bit tight for space. But yeah, that's the firmware. If I whack it up to the full voltage again, give you one more shot at it, and then that'll be the end. goes. Ooh. Had a bit of a stall then. A bit unexpected, but yeah. So that's that's my ongoing firmware and my home-built 3D printer. I hope you enjoyed it.